Hey everyone. So in this video, we are going to be looking at solving polar systems. So we're going to be looking at two polar equations at one time. You've done this before in Cartesian. You've solved system of equations. We will be doing the same thing, but now with polar. We're kind of doing all of Algebra 1 in the span of 2 weeks via video. Congratulations, guys. You guys are awesome. All right, so before we get started, I do want to kind of think about solving system of equations in Cartesian. So bear with me here for a second. If I gave you guys, let's see, y equals x plus 1 and y equals negative 1/2 x plus 4. All right, how would you solve this? All right, many of you would probably set them equal to each other. X plus 1 is equal to negative 1/2 x plus 4. That's true, and we could do that here in the polar as well. All right, you might also think to subtract the two equations to eliminate y, eliminating a variable. That's totally reasonable. You can do that here as well in the system of equations in polar. But I want to, in this video, focus on the graphical solution. So if I were to graph these two things, all right, x plus 1, that would be like, okay, so we have a y-intercept of 1 and then a slope of 1. Right. All right, and then x negative 1/2 x plus 4 let's say we have a y-intercept of 1, 2, 3, 4 would be up here, and then we'd have a slope of negative 1/2, so we're going down a little bit less steep than the previous one. And where is the solution to this system of equations? It is where they intersect. All right, so intersection points are solutions to system of equations. All right, that's the point we care about. All right, now let's jump back to what we're dealing with here. So we'll actually, let's figure out what it is real quick. So when do these intersect? Let's actually do it some way. X plus 1 is equal to negative 1/2 x plus 4. All right, so add 1/2 x to both sides, 3/2 x. Subtract 1 from both sides, 3, multiply by 2/3. The 3's are going to cancel. You're going to get x is equal to 2. And then plugging that back in, you're going to get y equals 3. So 2, 3 is our solution here. All right, so jump back to polar. The question I want to answer here is it sufficient to plot these things, see where they intersect, and those are our solutions? So if I plot 3 cosine 2 theta, and I plot r equals negative 3, and I get two graphs, and I get a bunch of intersection points, are those intersection points solutions? All right, one might intuitively say yes, but let's inspect. So let me go ahead and capture this first set of system of equations. Let's take it to this page right here. All right, let's graph these two things. So instead of point plotting this meticulously, I'm just going to get a sketch. So the first one is going to be, let's see, 3 cosine 2 theta. So that is x-axis symmetry. And we're going to have, it's a 2, so we're going to have 4 petals. This is a rose. And that is going to be a length of 3. So we're going to have 4 petals starting at 3. And if we're going to have symmetry everywhere, we're going to have a 3 up here. We're going to have a 3 over here. We're going to have a 3 down here. And there's our curve. And at what point do we cross through the pole? That's going to be when this thing is equal to 0. This thing is equal to 0 at, I believe, pi over 4. Cosine of 2 times pi over 4, that's pi over 2. Cosine of pi over 2 is 0. Good. All right, so we're going to have, this is going to approach 0, and it's going to get to it at pi over 4. All righty. It's going to pass through. All right, and it's going to come down here. Then it's going to come back up here. It's going to get to 3 pi over 4, but we're negative. It's going to pass through. You can get over here. We're graphing the first curve right now. It's going to come down this way. And we're now 5 pi over 4. Now we're negative. Now we're at 3 pi over 2. Now we're at 7 pi over 4. And we're back at 2 pi. So there is our first curve, a rose with petal length 3, and there are 4 of them, and it's symmetric about the x-axis. Sorry, what I mean by symmetric about the x-axis, this is a rose, not a circle. It's starting on the the polar axis. All right, so that's that curve. All right, I'm going to go ahead and give this a star so I remember that it's that lavender color. I'm going to go ahead and change this one to a different color. So we're looking at r equals -3. So at 0, we are at -3. All right, so maybe that's a solution. They're intersecting. And then as I increase my angle, I'm going to be graphing these points down here. Right? And then I'm going to create this circle. And we're actually going to get 2 of these circles in the span of 2 pi. So now I've graphed pi, and if I go around again, I'll get 2 pi. Cool. All right, so there are our 2 curves. So one might say that this point, this coordinate, that and this are all solutions, but you would be incorrect. And the reason is as follows. All right, when we're graphing it in Cartesian, right, we are graphing from left to right. And where they intersect, they're intersecting at that point at the same time, at the same input value. But that's not the case in polar, all right? And Michael Eiley has put together an amazing animation that I think exemplifies this really well. So let's go ahead and look at that. We are looking for when these 2 curves intersect each other, not just graphically, but at the same time, at the same theta value. All right, there, pi over 2 is a solution, but 0 and now pi are not. All right, theta equals 3 pi over 2 is a solution, but 2 pi is not, right? These graphs overlap at 0 pi and 2 pi, but they're not actually solutions. We care about when these intersect right there at the same time. All right, they're not intersecting there. They're at opposite ends of the graph, right? But there, at 3 pi over 2, specifically at -3, 3 pi over 2, you have a solution. Solving these things isn't that hard. I mean, all we got to do is set these 2 things equal to each other, but the emphasis that I'm trying to make here is that simply looking at the graphs and where the graphs overlap is not enough to know if it's a solution or not. Let's go ahead and solve this thing algebraically and establish the solution set that solve the system of equations. So let's see. -3 is equal to, so I'm setting these 2 things equal to each other. I could have subtracted the 2 equations, but here I'm doing this. All right. I'm going to divide by 3. Right, when is cosine 2 theta? When is cosine -1? That's at 3 pi over 2 plus 2 pi k. All right, that's what I need 2 theta to be. Oh, sorry, that's totally wrong. All right, when is cosine -1? That is at pi, so we want the 2 theta to be pi plus 2 pi k. And then if I divide by 2, I get pi over 2 plus pi k. So pi over 2 and 3 pi over 2 are solutions, but 0 pi and 2 pi are not, regardless of the fact that the graphs are overlapping here. We're looking at when these graphs collide at the exact same time, not just when the graphs appear to be intersecting. Right? That's different from Cartesian. Cartesian, if the 2 graphs intersect, then that is a solution. But that's because we're moving from left to right. There isn't this possibility of overlapping at different times. All right, so we're not completely done here. We have theta, but this is a system of equations, so we also need r. Oh, well, look, r is -3. And if I plug in pi over 2 into this thing, I'm going to get r is equal to -3 here. So my solution set is, let me go ahead and write this one in green, pi over 2. All right, so if my question is what are the solutions between 0 and 2 pi, pi over 2 and 3 pi over 2, and -3 and -3. So those are my two solutions. -3 comma pi over 2 and -3 comma 3 pi over 2. All right, let's do that second one. We had r equals 2 plus 3 cosine theta and r equals 6 cosine theta. All right, there we go. There's our graph. All right, let's, we can do one of two things. We could solve this system algebraically and know the answers. I'm going to go ahead and graph them just to emphasize this new idea that intersection points doesn't necessarily mean it's a solution. So this first one is going to be a limacon. That 3 is larger than the 2, so this is going to be a looped limacon. All right, it's cosine, so our maximum is going to be 5. All right, I'm going to do this one in green. And then we are going to loop down. We are going to be at pi over 2. We're going to be at 2. Right, at pi, we're going to be -1. And then at 3 pi over 2, we're going to be -2. And then at 2 pi, we're back at 5. We're decreasing. Right, this problem is not necessarily about accuracy in our graphs. So I'm not going to worry too much about like specific points. I'm not going to worry about the tangents here. But I know I'm passing through. All right. All right, so another thing that's useful is to write down where you start, so we can kind of imagine when these are intersecting. All right, let's go ahead and do the other one. All right, so 6 cosine theta, that's going to be a circle that starts here, and it's going to end up there. It's going to be about, what is that going to be? What happens when I'm at pi over 4? Let's get that. So cosine of pi over 4 is root 2 over 2, so this is going to be 3 root 2. Which is 4.2-ish. So at pi over 4, we're going to be at 4.2-ish. And then down here, we're also going to be at 4.2-ish. And we are a circle. Okay, cool. All right, so this might be a solution. It might not be. We need to inspect more. This also might be a solution, but we need to inspect more. All right, and this right here, this origin point, that might be a solution, but we need to inspect more. All right, where did the purple start? It also started here. All right, so you can kind of imagine that this is, in fact, going to be a solution because both of the graphs start here and here. Right? So they're going to move in a counterclockwise manner, and ideally they're going to intersect there. But this purple circle is going to get to the origin, the pole, way before this green graph. Right? This purple circle is going to get to the pole when the green graph is right here. Right? So I think they're going to miss each other. When this green graph gets to the pole, I believe the purple is going to be at -1. Right, so they're not going to collide, I think, here. Right, we'll look at a graph. We'll look at an animation in a second. Right, but then they go about their way, and I believe they will be intersecting here. So there are two solutions to this. I believe this coordinate here at the pole is not going to be a solution. That intersection point is not a solution. Let's look at an animation. All right, so see, they start at the same spot, and boom, they collide right there. But they do not collide at the pole. They are not getting to the pole at the same time, right? That circle is making a second revolution. And then, once again, they don't collide at the pole, but right There they do collide. Those are our two solutions. Right? Let's look at that one more time. All right, we're looking at when these things are colliding at the same time. We have an approximate radian value right there at the top, around 5-ish, 5.2, 5.3, something along those lines. All right, let's solve this thing. All right, so set these two things equal to each other. 2 plus 3 cosine theta is equal to 6 cosine theta. Right? I'm going to go ahead and subtract 3 cosine from both sides and get 2 is equal to 3 cosine theta. And then divide by 3. And then our answers are theta is equal to, I'm getting the answers between 0 and 2 pi here. So arc cosine of 2/3 and 2 pi minus arc cosine of 2/3. All right, what exactly is arc cosine of 2/3 and 2 pi minus arc cosine of 2/3? That is what a calculator is for. And that is 0.841. Of course, this keeps going. And 2 pi minus that, which is 5.442. All right, and then if we want the final solution to this system, we need r. So let's go ahead and plug this thing back in. So we got r is equal to 6 cosine, and then let's plug in the first angle, arc cosine 2/3. And very conveniently, the cosine and the arc cosine will interact with each other in a very easy way. So cosine of the arc cosine is going to be 2/3. And 6 times 2/3 is 4. All right, so this coordinate right here is 4, comma, arc cosine 2/3. All right, clearly my graph is a little bit off. They should have intersected way up here. My green graph should have been a little bit more wide. But that's my bad. All right, the actual solution is 4 arc cosine 2/3, and then down here we got 2 pi minus arc cosine 2/3, and 2 pi minus arc cosine 2/3. That's going to be still 2/3 when I take the cosine of that, so that's also going to be 4. Cool. If you double back to Michael's animation, you'll see that they do intersect at 4 units away from the pole. Still at arc cosine 2/3 and 2 pi minus arc cosine 2/3. All right, I got one more for you just for practice sake. Preset it up right here. We got 5 sine 2 theta and 5 sine 4 theta. So this is mainly also to get practice with graphing these roses. So 5 sine 2 theta, we have a petal length of 5, and we're going to have 4 petals. Down here, we're going to have a petal length of 5, and we're going to have 8 petals. All right, this is sine, so we're going to be starting at the origin. So this one I'll do in white. So we're starting here. And then at pi over 4, we're going to be at that maximum point, which is 5. So we're going to be way out here. All right, so I'm going to go ahead and get this graph sketched. Give me 1 second. Go ahead, fast forward if you need to. This is a good time to remind you guys to attempt these problems before I do it. All right, that's 1 petal. All right, this is going to go straight through right there. The next petal is going to be over here. We're going to have a negative length of 5 at 3 pi over 4. Go straight through here. Now we're going to be at 5 pi over 4. We're going to get over up to positive 5. And then last but not least, we're going to get to 7 pi over 4 negative 5. Cool. So not the best, a little bit sloppy, but nonetheless. There is our first graph, and then let's go with orange for the second one. We're going to have a similar graph, but with 8 petals. All right, so this is going to be nice. Our first petal will be at pi over 8. And then we're going to... All right, we'll be at the pole at pi over 4. We'll come out on the other side. We'll be at negative 5 at 3 pi over 8. And we'll come up here to this point. Three pi over 4. We're going to be coming back through. And then we'll come out here to this point right here. And that's 4. And then we're going to be down here. You get better at this with time. Like, I'm still not that good, to be honest. Through. Now we're going to be up here. I'm taking advantage of symmetry to graph this a little bit more efficiently. Come through. Right here. My petal length is always 5, so that's makes it kind of easier. I'm gonna be over here. All right, I'm always working pi over 8 away. Half pi over 4. Cool. Oop, that last one was a little bit too far. Let me backtrack. I should have gone to there. Sorry about that. Let's come from over here. Didn't look right, so I inspected what was wrong. Petal length was wrong. All right, there we go. So we are these two graphs are intersecting all over the place. And I want to know what are the solutions to the system of equations. And it's not enough to just look at this graph. We kind of need to see how it graphs itself. So let's go ahead and look at an animation. All right, here we go. There we go. There's one. There's another right there at the pole. There's one. There's another at the pole. There's one. There's another at the pole. There's one. There's another at the pole. So there were 4 at the pole, and I believe 4 not at the pole. Let's look at that one more time. 1. Let's ignore the pole ones. 2, 3, 4. All right, so there's 4 out there, not the pole, but I believe these two graphs intersected the pole 4 times too. Once, not there. Twice, not there. There, 3 times. And at 2 pi. There you go. So we have 8 solutions here. All right, how do we deal with this? We solve the system of equations algebraically, and that'll tell us exactly which of these, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 possible solutions, but there are only 8 actual solutions. All right, so let's solve this system here. Here we go. All right, 5 sine 2 theta equals 5 sine 4 theta. So the 5s don't matter. We're really solving sine 2 theta equals sine 4 theta. Sine 2 theta equals sine 4 theta. All right, solve this the way you want. I'm going to use the double angle formula. So sine 2 theta is equal to 2 sine 2 theta cosine 2 theta. All right, and then I'm going to subtract and then factor. So 0 equals 2 sine 2 theta cosine 2 theta minus sine 2 theta. And then 0 is equal to, I'm going to factor out the sine 2 theta. So sine 2 theta times 2 cosine 2 theta minus 1. All right, so we need to set these two things equal to 0. All right, sine 2 theta is equal to 0, and cosine 2 theta is equal to 1/2, and that's going to give us our solutions. So let's do it. All right, sine 2 theta is equal to 0 when 2 theta is equal to pi k, and so theta is equal to pi over 2k. So what is that in terms of between 0 and 2 pi? Pi over 2, pi, 3 pi over 2, and 2 pi, and or 0. All right, and then the other thing we needed to solve, cosine 2 theta is equal to 1/2. All right, when is cosine 1/2? It's 1/2 at pi over 3 plus 2 pi k, and also 5 pi over 3 plus 2 pi k. All right, cool. And then if I divide by 2, I'm going to get theta is equal to pi over, what is that, 6 plus 2 plus pi k. And 5 pi over 6 plus pi k. All right, so we have 1, 2, 3, 4, and then we have 2 more solutions here. So this is just pi over 6 and 7 pi over 6. And this over here is 5 pi over 6. And plus 6 pi over 6, that's 11 pi over 6. So 1, 2, 3, 4, 5, 6, 7, 8 solutions. And what are the R values that go with each of these? Let's go ahead and figure that out. You know what? I'm just going to tell you guys what it is. All right, if you plug in any of these back into either of your systems, you're going to get a sine of pi, and sine of pi is 0. So this is going to be 0, 0, 0, and 0. All right, this is going to correspond like this. All right, and then if you plug these back into the system of equations, you're going to get 5 root 3 over 2, 5 root 3 over 2. This is if you plug it back in, and this is going to give you negative 5 root 3 over 2, and similarly negative 5 root 3 over 2. Ran out of room there at the bottom. Sorry. Yeah. So there you have it. That is solving systems of equations in polar. If you want to just solve it algebraically, you don't have to worry about anything. It is exactly how we've always done it. But if you choose to solve graphically, or you need to be careful because sometimes intersection points are not solutions. Go back and look at those sweet animations. All right? But that's the big idea here. All right? Solving system of equations in polar. Just be careful. All right. That's it for this video. I will see you guys on the flippity flop.